then you don't have to worry.
Right. So as you can see, this tool shows the battery, which provides the power supply to the BJT. So any active component needs power supply. Okay. So in this case, be it 15 plus minus 15 watt, plus minus 12 watt, or plus minus 10 watt.
Oh yeah, Sunday can be a problem because I need to go set fuel for MITP. May be able to come only after that. Need to boot fuel. Yeah, let's go spark.
So when you treat it as shorter, actually one
yeah, I'm staying Saturday. What's BJT?
So basically you have an input voltage here, and you have output voltage.
What the fuck is a transistor? Yeah. Looks so foreign to me.
BJT like diode, okay? You can only pass current in one direction. So if you connect your battery reversely, it's going to no current will be run through the BJT. So if you have your configuration in this way, and your input is no longer a DC power supply, AC, so it will have half the waveform, so run in the reverse direction. So in this way, your BJT will have current in half of the time. So in this way, actually we call it half rectifier, so that you have a full wave, full sinusoidal wave input, while in the output here, voltage and C and D, you will have half wave, so we call this half wave rectifier. The problem with this half wave rectifier is not power efficient, because you can imagine it cut off actually half of the waveform. So if we change
AC power source and a DC, that's a DC, right? 15 volt.
If we change the configuration, we will have a full wave rectifier. So for sinusoidal input, you will have a sinusoidal output as well. But you were experiencing some distortion at the crossover point, okay? So this is due to the threshold voltage. As we see from the first slide, BJT must work under a minimum threshold voltage. Next will be Op Amp, right? Op Amp is another important active component.
I'm
configuration. It is just to show you that actually Op Amp can be used to build rather complicated circuitry. And
operational amplifier. Wow, look at that circuit.
5 terminals in Op Amp. All right. So we call this positive terminal. And terminal 3 is the output terminal. And of course, for any active component, you need a power supply, DC power supply. So this terminal will connect to the, let's say, battery positive end, okay? And then this terminal will connect to the negative pole. If you look at the configuration of how to connect your power supply, you can treat these two as your battery. Alright, so do remember the grounded point, okay, is in the connection point of two batteries. So it's not at the negative end. So for your op amp, actually no terminal is actually grounded. Alright, so do remember these. And as you can see, the so usually okay, the input can be supplied from terminal 1 and the terminal 2. If the input is supplied from the negative terminal, we call it inverted configuration. If the input is supplied from the positive terminal, we call it non-inverting configuration. Reason being, this op amp is considered as different amplification. In the meaning of the output actually is the amplified signal of the difference of the both terminals. So the output actually can be written as, again, times the difference of V2 and V1. And the difference of V2 and V1 is V2 minus V1. So you can imagine the output terminal, the output signal actually is in phase with the positive terminal. That's why if you supply input through the positive terminal, it is non-inverting. Non-inverting is do not invert, okay? And if you supply the input from the negative terminal, things are, your output is just with different sign as terminal 1. Terminal 1 is minus 1, minus V1. So it is actually in phase, it has actually 90 degrees phase difference. Sorry, 180 degrees phase difference. So we call it inverting configuration. Alright. And there's another important assumption is the input impedance, okay, looking from the input, looking at the op amp from the input, the input impedance is infinite. So there's no current draw into terminal 1 and terminal 2. This is for ideal case, of course. It is assumed that infinite big input impedance. Alright. But usually the input impedance is in a mega ohm level. So it is considered very big. And if you look at the op amp output, actually it has ideally 0 impedance. So ideal op amp has 0 output impedance, so that it can actually drive any load ideally, because from output to the ground, okay, you can 1 will be seen at terminal 2, so in terms of voltage. So usually for the configuration, if you have measured voltage at terminal 1, so you will see the same voltage at the terminal 2. So you can see these are two configuration. This one is actually the inverting configuration as the source or the input was injected from the negative terminal. And for this case, the source or the input was injected from the negative, from the positive terminal. So this is called non-inverting configuration. So do bear in mind, okay, according to the Kirchhoff circuit, Kirchhoff law for the voltage, so the voltage, the summation of the voltage in any closed loop circuit will be 0. So the output, as you can see, since our power supply, the output voltage will be limited by our power supply. So E will not be exceeding the power supply. All right. So maximum value will be the maximum value of power supply, and the minimum value, of course, is the minimum value of power supply. So in this case, as you can see, so our output should be in the range of 0 to 30 volts. And for this configuration, the output should be in the range of positive minus 15 volts. All right. This curve actually just show that the output is amplified difference it is when it's bigger than VR, LED will be off. All right. Sorry. When it's bigger than VR, LED will be off. For this case. Right. And if Vin is below VR, so this case, so the LED will be on. In the end, our output voltage will become a square wave. Okay, and its duty cycle will be determined by this VR, the voltage that the input was transferred to. So this shows another case where VR is slightly bigger. So you can see the duty cycle is actually bigger. All right. So if you further reduce the duty cycle, further reduce the VR, the duty cycle will be decreased. All right. Just now we talked about the inverting configuration and the non-inverting configuration. So these slides actually show that the op amp, what we have talked before, is all based on an open loop configuration. Means we only have input and output, and our input and output has no connection. So if we connect our output back to the input, we're going to feedback. All right, we feedback the output to the input port. So depends on you feedback your output to the negative terminal or positive terminal. If you feedback your output to the negative terminal, we call it negative feedback. Okay. So if you feedback it to the positive terminal, then it is a positive feedback. It's very similar to what you have learned in control. It's actually the same as negative feedback or positive feedback you learn in control. So as you can see, now the negative terminal is no longer any input, it's actually output itself. So the difference between the positive terminal and the negative terminal is actually Vin minus V minus V out. Okay, so it's Vin minus V out, and times the gain. Okay, is the V out. So solve this algebra, we can get our output is actually input times gain divided by gain plus 1. Okay, as we know, the gain is infinite thing. So if we treat this as a final number, gain plus 1 is actually approximately equals gain. So gain divided by gain is 1. In this way, output is actually approximately equals input. All right. So this is one simple application of op amp using the negative feedback. So as you can see, if we use this configuration, the output will be almost the same as input. Why do you see something here? Is because gain is not infinite. Okay, so it has some value. So there is some drift here, but comparably and approximately they are equivalent. So this is if you do some round off, of course you can get exactly the same voltage. Okay, so compared to 6 volts, of course, 29 microvolt is extremely small. So let's look at two configurations in details.
What the fuck, man?
The first one, we look at the inverting amplifier.
I hope you can see.
So the way to analyze the circuitry with op amp is always assume that the amplification is infinite. So it is infinite. So
out the notes.
positive
You copy from him.
So V2
Can copy from him.
is equal to V1. So things, as you can see, the input was injected from negative terminal. So positive terminal is grounded. So V2 actually is 0. And according to what you have seen in terminal 2 will be seen in terminal 1. So the voltage at terminal 1 is also 0. Okay, so this is very important conclusion. And according to the Ohm law, this is positive and this is 0. So the current will always flow from positive to negative or from a lower path, right? So actually the direction of the current, the original slide is wrong. Okay, so it's towards the right. And according to the Ohm law, you know the difference of the voltage. So you know the voltage at these two ends is 6 volts, right? Because this is 0, this is 6. So the current can be derived, can be calculated by the voltage divided by the resistance. Okay. And again, according to the Ohm law, things, the impedance, all right, is approximately 0. Okay, looking from the output terminal, the op-amp's impedance at the output is approximately 0. So the current will always flow from the lower end. So the current flow through the resistor R2 will be towards the right as well. Okay, and this value is also equivalent to I1. Okay, the current runs through R1. And so the voltage on R2 is actually V1 minus V out. Okay, VO or V out. And so that we have this relationship. All right. So the gain of this negative feedback system actually can be derived by the ratio of output versus input. Okay, so we have obtained the output, which is minus VI divided by R1 times R2. And our input is VI, so this VI has been cancelled out. We get our gain, okay? The amplification gain becomes minus R2 over R1, okay? Not positive, okay? Okay. So, as you can see, for the open loop configuration of op amp, its amplification gain is approximately infinite big. It's very big, okay? But due to connect the output to the negative terminal, the amplification gain actually becomes a finite number, which is determined by the two resistors that you connected. All right. So of course, this is all based on the assumption that the open loop gain, amplification gain, is infinite big. If A is not infinite, we have this relationship, okay? Use the same method to derive. Of course, looking at this relationship, if A is very big, so we can actually derive this relationship. Okay. So this is a special case when A is infinite. Okay. So when A is infinite, you can always come up with this solution. So the one on the left is the non-inverting amplifier. The input was actually injected to the positive terminal. So according to the same analysis, what you have seen here, 6 volt at terminal 2, at positive terminal, will be seen at negative terminal. So V1 or the voltage at the terminal negative terminal will be 6 volt as well. Okay, so this is the most important relationship. And here is grounded, so this is the lower end, and this is 6 volt. So the current will run towards the left. Okay, the one on the slide is also wrong. Okay, and the current can be calculated by using the ohm law as well. Here. Because of the infinite impedance at the input of op amp, the current will flow through R2 in this way as well. Okay. So the voltage on resistor R2 is actually the difference between this point and this point. Okay, so it's VR minus V1 or VI. Alright, VI is V2, V2 is V1. Alright, so we have the relationship of, we can solve what is the output now. Okay, and the amplification gain is the ratio of output and input. Okay, is actually 1 plus R2 over R1. So as you can see, for the non-inverting configuration, the amplification gain becomes 1 plus R2 over R1. Again, this is dependent on what R1 and R2 you're using. Of course, you can have different configurations, no matter they are inverting or non-inverting, and the op amp can be used to build integrator, differentiator, and instrumentation amplifier. Okay, so it's different configurations. For the above configurations, we can actually use the non-inverting configuration.
Got so much studying to do.
To
fuck, man.
actually transmit
I know. So fuck.
signal as current instead of voltage. Reason being,
Okay, I also don't know who really watch it.
the voltage, the output voltage, okay, as you can see.
I think I will be